Okay, some important properties of logarithms. We need to move a little forward. Evaluating logs isn't going to be too bad. You're going to trial and error it, or if it's log base 10, you're just going to pump in your calculator. And we're going to move forward with some other properties. So here are the following properties. We need a greater than 0, so we're not talking about a ever being negative, and we're not talking about a not equal to 0, and we're not going to have a equal to 1. And the reason for these restrictions will be clear in just a few minutes. The exponent I put on a to get 1, anytime you want to get answer 1, the exponent has to be 0. So if you've got a to the power of something, doesn't matter what it is, if your answer wants to be 1, you're going to be exponent 0. And you see, that's why we put a greater than 0. We don't want negative numbers down here, and we don't want 1, because 1 to the exponent 1, well, it does work for 1, but 1 is it's a special case when it comes to exponents. Anyways, the exponent I put on a to get 1 is 0. It doesn't matter what the a is within these restrictions. The exponent I put on a to get a to the x, this is what we just ran into a minute ago. What exponent do you put on a to get result a to the x? X. And don't go any farther until you think that over and make sure that that is like clear and easy to understand. If you have something base a and you've got to put an exponent on it and you need the answer to be a to the power x, the exponent's got to be x. So this log a and a to the x kind of cancel each other out. And vice versa. A to the power of the exponent you put on a to get x is x. So if you're putting the exponent on, this is what this is. It's the exponent you put on a to get x, and you're putting on a, answer x. Hey, a little proof for that last one. Why not? Here we go. Let y equals a to the log a x. So that's what the left side is. If we write that in logarithmic form, that is, the power I put on a to get y is log a of x. So the power I put on a to get y is log a of x, and you can see log ay equals log ax. The log a's are gone, and then y equals x. So that means this answer to this side is x. We've proved that the answer to the left side is the right side. Here's an example covered up by my little record thing. Let me just move it over here. You can fit up here now. Okay, so 4 to the power of log base 4 of 7. So we've got 4 to the power of the number I put on 4 to get 7. So the exponent is the number I put on 4 to get 7, and it's on 4. Answer, 7. Rewind that and listen to it again if it's too confusing. I'll say it one last time here. I'm looking for this exponent up here is the exponent we put on 4 to get 7, and it's on 4. So I get 7. And that's the end of the slideshow. Enjoy the homework, and have a good day.